So our next question is, if x power y is equals to e power x minus y, then show that dy by dx is equals to log x by 1 plus log x whole square. Okay, so we need to find the differentiation of this term and we'll get that. So the given equation is x power y is equals to e power x minus y. So we should apply log on both sides. Apply log on both sides. We get log x power y is equals to log e power x minus y. So we can take the base as e. Okay. Now here it is log a power n. So it is n log a. So the power comes first. So it is y log x equals to, here also it is the same, x minus y into log e to the base e. So the value of log e to the base e is 1. So it is y log x is equals to x minus y into 1. Here we'll shift this y term to that side. So it will be x is equals to y plus y log x, right? Taking y common here, so it is x equal to y common 1 plus log x. Now shifting this term to that side, so it will come in the denominator. So y is equals to x by 1 plus log x. Now differentiating both sides with respect to x on both sides, so it is dy by dx is equals to d by dx of x by 1 plus log x. Now we should use the formula of u by v. U by v derivative, which is equals to v into u dash minus u into v dash by v square. This is the formula you need to remember. Okay, so the numerator is u and denominator is v. So it is dy by dx is equals to v is 1 plus log x. So it is 1 plus log x into u derivative. So it is x derivative minus x into v is 1 plus log x derivative by v square is 1 plus log x whole square. Now dy by dx is equals to 1 plus log x, as it is x derivative is 1 minus x into 1 constant derivative is 0 plus log x derivative is 1 by x. Okay, so here this x and this x gets cancelled by 1 plus log x whole square. This can be written as 1 plus log x into 1 is the same thing, and here it is minus 1 by 1 plus log x whole square. Here minus 1 and plus 1 gets cancelled. So our equation becomes dy by dx is equals to log x by 1 plus log x whole square. So our next question is, if sine y is equals to x into sine a plus y, then show the derivative of this equation is sine square a plus y by sine a. So the given equation sine y is equals to x into sine a plus y. Okay, now shifting this term to that side, so our equation becomes x is equals to sine y by sine a plus y. Okay, now differentiating with respect to x on both sides, so x derivative is 1 is equals to, here it is in the form of u by v derivative, which is equals to v into u dash minus u into v dash by v square. Okay, now we have to substitute in this formula. So it will be v value is sine a plus y into the derivative of the u value, so it is sine y derivative minus u value is sine y into sine a plus y derivative by v square. V value is sine a plus y square. So here only it is sine square, not this, because this is like the angle theta. So we cannot put this square, so it is only sine square. So this becomes 1 is equals to sine a plus y. Here the derivative of sine y, sine x derivative is cos x, so here it is y, so it is cos y. This is not x, so we'll write the derivative of the y term, so it is into dy by dx minus sine y. Again it is sine x derivative is cos x. Okay, so sin x derivative is cos x, so this was not x, so derivative of it again, so a is constant, constant derivative is 0, plus y derivative will be dy by dx whole by the same sine square into a plus y. So here we'll write dy by dx as common once only, so sine a plus y into cos y minus sine y into cos a plus y by sine square a plus y into dy by dx. Okay, so this becomes the formula now. This is sine a cos b minus sine b cos a, so it will be equal to sine a minus b, so a is a plus y minus b is y by sine square a plus y into dy by dx. So here plus y minus y gets cancelled. Now we'll cross multiply this term to that side with 1, so it will be sine square a plus y is equals to sine a into dy by dx. The sine a comes over there, so it will be division, so it is dy by dx is equals to sine square a plus y by sine a. So the question is, if y is equals to x power y, then show the derivative of this equation is y square by x into 1 minus log y is equals to y square by x into 1 minus y log x. Okay, so the given equation is y is equals to x power y. So in order to solve this, we need the log term. So applying log on both sides, so it is log y is equals to log x power y. So this comes in the forward, right, using the formula log a power n is equals to n log a. So this will become y log x. Now differentiating with respect to x on both sides. So this will be log x derivative is 1 by x. So here it is y. So it is 1 by y. This is not x. So derivative of y again. So it is dy by dx is equals to, here it is u into v formula. So it is u v derivative is equals to u into v dash plus v into u dash. We should write this formula. Okay, so here take this as equation 1, we will use this later. Okay, so here u is y into v is log x derivative plus log x into u derivative is y derivative. So here this can be written as 1 by y into dy by dx is equals to y into log x derivative is 1 by x plus log x into y derivative will be dy by dx. Now grouping the term of dy by dx, so this term goes to that side, so it will be 1 by y into dy by dx minus log x into dy by dx is equals to 1 into y is y by x. Now taking dy by dx common, so it will be 1 by y minus log x is equals to y by x. Now taking LCM over here, so it will be dy by dx is into 1 minus, so here it is 1, so it is 1 into y, so above also y log x by y is equals to y by x. Now transporting this term to that side, so it will be reciprocal. Dy by dx is equals to y by x. So this reciprocal becomes y into 1 minus y log x. So this will become y into y is y square by x into 1 minus y log x. Okay. Now from equation 1, the value of y log x is equals to log y. So in the place of y log x, we can substitute log y. So this is also equal to y square by x into 1 minus log y. If f of x is equals to tan inverse of root 1 plus x square minus 1 by x, and g of x is equals to tan inverse x, then differentiate f of x with respect to g of x. So in this question we need to find the derivative of f of x with respect to g of x. So the formula, the derivative of f of x with respect to g of x is given by f dash of x by g dash of x. So here we need to differentiate both the equations f of x and g of x, then we should divide both, so we'll get its derivative. So the given function f of x is equals to tan inverse of root 1 plus x square minus 1 by x. So here we need to put x equals to tan theta, put x equals to tan theta, bringing tan here, so theta is equals to tan inverse x. So now substituting the values of x here, so it is f of x is equals to tan inverse root of 1 plus tan square theta minus 1 by tan theta. Here we know one formula, which is 1 plus tan square theta is equals to secant square theta. So here it is in the root. So secant square root means square and root gets cancelled. So we'll be left out with secant theta. So it is tan inverse secant theta minus 1 by tan theta. Now for secant we'll write it as 1 by cos, and for tan it is sin by cos. So f of x is equals to tan inverse secant 1 by cos theta minus 1 by sin theta by cos theta. So here taking the LCM in the numerator term, so it is 1 into cos theta and here into 1. So it is tan inverse is equals to 1 minus cos theta by cos theta whole by sin theta by cos theta. So this cos and this cos gets cancelled. So we'll be remaining with f of x is equals to tan inverse 1 minus cos theta by sin theta. Now you need to remember two formula, which is 1 minus cos theta is equals to 2 sin square theta by 2. This is 1. And sin theta can be written as 2 sin theta by 2 into cos theta by 2. This is the another formula. Now substitute these two formulas in here. So it is f of x is equals to tan inverse 2 sin square theta by 2 by 2 sin theta by 2 into cos theta by 2. So 2 gets cancelled and one sign gets cancelled. So we'll be remaining with sin theta by cos theta, which is equals to tan theta. So it is f of x is equals to tan inverse where with sin theta by 2 by cos theta by 2, which is equals to sin inverse tan theta by 2. Here tan inverse and tan gets cancelled. So f of x is equals to theta by 2. So the value of theta is tan inverse of x. So we can write this term as 1 by 2 tan inverse of x. This value is of f of x, right? Now we should differentiate it. Okay. So we'll get f dash of x. So f dash of x will be equals to 1 by 2 is the constant term and tan inverse x derivative is 1 by 1 plus x square. Okay, so this is the value of f of x. Now g of x value is given in the question as tan inverse of x. Now we'll get the value of g dash of x, which is equals to 1 by 1 plus x square. So we got the value of f dash of x and g dash of x. Now we should divide the both, so we'll get its derivative with respect to g of x. So it is f dash of x by g dash of x, that is equals to 1 by 2 into 1 by 1 plus x square by 1 by 1 plus x square. So these two terms are same, they get cancelled. So it is equals to 1 by 2. Find dy by dx for the function x is equals to a into cos t plus t sin t and y is equals to a into sin t minus t cos t. So we are having two functions x and y. So x is equals to a into cos t plus t sin t and y is equals to a into sin t minus t cos t. So now we'll differentiate with respect to t here, as there is a function of t, right, with respect to sine and cos. So it is dx by dt is equals to dx by dt into a into cos t plus t sin t. Okay, so it is dx by dt is equals to, here a is a constant term, we'll write as it is, cos x derivative is minus sine. Okay, so minus sine t, and this is okay, t derivative will be 1. Next, here we will use u into v formula, which is u into v dash plus v into u dash, right? So this will can written as t into sin t derivative plus sin t into t derivative. Okay, so this will be a into minus sin t plus t into sin t derivative is cos t, and here plus sin t will come and t derivative is 1. So here plus sin t and minus sin t gets cancelled. So it is dx by dt is equals to a into t cos t. So we can write it as at cos t. Okay, in the similar way we should differentiate y function. So it is dy by dt is equals to ty by dt of a into sin t minus t cos t. Okay, so it is dy by dt, a is a constant term, and sin t derivative is cos t minus again here u into v it is, so it is negative of t into cos t derivative plus v value is cos t into u derivative is t derivative. Okay, so it is dy by dt is equals to a into cos t minus t, as it is cos t derivative is minus sin t plus cos t into t derivative is 1. Okay, and this minus need to be multiplied. So it is dy by dt is equals to a into cos t. So this minus of minus becomes plus, so it is t sin t, and this plus into minus becomes minus cos t. So plus and minus cos t gets cancelled, so we'll be remaining with a into t sin t, that can be written as at sin t, which is the value of dy by dt. Now we have to get dy by dx. So dy by dx, in order to get, you should divide this 2. Okay, so it is dy by dt by dx by dt. So the dt gets cancelled. So this function is at sin t by at cos t. 80 gets cancelled. Sin by cos is tan. So it is tan t.